Efficiency. It describes the energy that a certain system can extract and make useful. It's from an energy source. Any system that uses this energy source from fuel, for example, has an efficiency. All of them. So for example, let's say one of them, like coal, has a 32% efficiency. That means for every 100 joules of heat energy, only 32 joules of it actually becomes electricity. And obviously electricity for light is our useful work, right? The rest of it, the difference, the rest of it just gets dissipated as heat, which is useless to us. Also, efficiency does not equal effectiveness. Okay, efficiency is pretty much what's talked about up here, the extractfulness of the useful energy. Effectiveness is simply the making use of the energy to do the right goal. So if you have two cars, for example, and both take you from point A to point B, both are equally as effective. One might be better in terms of mileage, right, of using the useful energy than the other, right? So it's better efficiency, but both cars are equally effective because they do the same goal. Next, we have percent efficiency is equal to the E out over E in. E out is the two mediums that are surrounding the system that is releasing the energy. So if we have ethanol here that is being burned and it's releasing energy, the glass beaker and the water is surrounding it. They're absorbing the amount of energy that is coming out of the ethanol. So these are going to be the E out. The E in is the ethanol here that is being burned, that is releasing a certain amount of energy, theoretical value. And as you can see, the theoretical value here for the molar enthalpy of ethanol is this much kilojoules per mole. Now we're just going to get our Q for both of these. So we just got all our values over here, and we're just going to get our degrees Celsius. So just going to be 33.2 degrees Celsius if you get the difference between these two. This will also be 33.2 degrees Celsius. You just add these two together, you end up getting your Q total. Once you have that, you have to find the total amount of energy that is being released from the ethanol. So I'm just doing that over here. Delta H is equal to moles times my delta HR. Our delta HR ends up becoming delta H cohm, and they tell you what it is in the question. So we're just going to have to find our unknown mole value. Well, I've gotten 1.24 grams of ethanol as shown here in the question, and then we just have to multiply by our molar mass. So we cancel out our grams, so we just get our moles. So now we find our moles. So I'm just going to get this moles. I'm going to put it here. So I have 0.0269 moles. And then I'm just going to cancel out the moles so that I end up just getting my kilojoules. This is the amount of energy in, right? The amount of energy that is being released from the ethanol. I'm just going to quickly change this into the joules value. And then again, our in is in here. And then our output is going to be on the top. So I'm just bringing this one all the way over here, and I just divide them, and then I multiply by 100%, I get 78% efficiency. I want you to try this here, the green question of the day, and I'm going to give you the answers shortly. Please pause the video and give it a try on your own. This here is the answer.